At a place called Cape Ball on the east coast of Graham Island, which is the largest of the Queen Charlotte Islands, we discovered a sea cliff site that exposed an ancient lake bed or a pond bed which contained lots of plant material and pollen. And when we dug to the very bottom of this exposure and obtained some plant materials for radiocarbon dating, we came up with the amazing radiocarbon age of 15,000 years ago or so. And that was very contrary to what everyone knew about the coast between here and Alaska up to that time, where everyone had thought the ice age ended about 12,000 radiocarbon years ago. But the discovery here was that this age of 15,000 years or so made the Queen Charlotte Islands, at least that part of them, at least 3,000, maybe more years older in terms of being deglaciated early after the ice age than anywhere else known on the BC coast. So here we had the first inkling that maybe this is part of the explanation for the unusual plants and animals there. They've had at least 3,000 more years to evolve. But it also gave us the first window on what these really early near glacial landscapes might have looked like. Certainly there was no evidence of trees at that time. It was very much more tundra-like, and we discovered remains of plants that are now actually missing from the Queen Charlotte Islands or extremely rare, such as some of the dwarf willows, some Jacob's ladder, which is a beautiful flowering plant that was only known from one location on Limestone Island in the Queen Charlottes. And these things were turning up virtually wherever we looked in these older sediments at Cape Ball. So we had an inkling that things had changed dramatically since the early days, when basically we had what looked like a non-treed, open, tundra-like environment on the Queen Charlottes, pretty much as you'd expect for the end of an ice age. And then we actually recorded the transition to the arrival of the first trees, which were lodgepole pines, followed by 1,000 years later approximately by spruce, and then later yet hemlock. And this transition turns out to be a very important aspect for later theories on coastal migrations of people, because the best date we have for the first appearance of trees on the islands is around 12,500 radiocarbon years ago, when we find needles, pollen, and wood of lodgepole pine, and thereafter a number of other trees. Before that time we have this very open landscape which looks much more like the treeless Aleutian Islands today off the coast of Alaska and other sort of coastal tundras much further to the north. So we have an analog at that time for what this early environment might have been like, all the way from the Queen Charlotte Islands all the way up to Alaska and perhaps to the Bering Straits, where environments like this are still present today.